Greetings folks, in this video I'm going to be showing you how to set up a plane for FPV using ArduPilot instead of iNav. I'm very familiar with iNav, been using it for about 6 years and I'm very comfortable with it. Not so comfortable with ArduPilot, but I have the FIMI Manta VTOL plane coming from Banggood, and that runs on ArduPilot, so I figured I need to know a little bit more about it. And this is as much for my benefit as yours, because I need to record this stuff so that I can remember it in the future, because I know I'm just going to forget it as soon as I stop using it. It's going to be using the F405-Wing board, Express LRS, Radiomaster Boxer with the Express LRS module in the back. I'm going to be putting it on the LTE Rambler, mainly because that has really good access to flight control board area and small enough to have on my desk to set up. Now, there are a few videos out there, but they're all based on using Mission Planner and a PC. I don't have a PC, I have a Mac. So I'm going to have to use one of the Mac-friendly ground station or configuration programs, and that is APM2 or QGroundControl. QGroundControl is the one that I've been using, so that's what we'll be doing. ArduPlane, QGroundControl, F405-Wing board, Elevon plane on a Mac. ArduPilot is, unlike iNav, it assumes you're going to have a ground station, which is like a laptop connected via some radio to the model while it's flying. You can also have RC control, which is what I'm doing. It also assumes you're going to have a GPS, airspeed sensor and compass. Now I'm only going to have the GPS, I'm not going to have compass and airspeed sensor, so we have to remember to disable them. So yeah, it's designed for fully autonomous flight actually, but what I'm going to do is just try and emulate iNav and have just a nice flying safe FPV plane with return to home and GPS activated modes as well. So our first step is to download and install QGroundControl. We just go to QGroundControl.com. Download whichever version you want. There's a Windows version or a Mac version. Just download the DMG and install it on your Mac. This is what it looks like. Being a ground station, it does come up with a map, but it is also a configuration program. So that's what we're using it for. We click up here, Vehicle Setup. Then you can see all the setup screens. And we'll work through a lot of these to properly set up the flight control board. Now, F405-Wing board, as always, you should go to the Matek website and have a look at what they have to say there. They do have an ArduPilot set up here, so that gives you tips where to get the information on the ArduPilot website and where to plug things in. Scroll down the bottom, I'm using Express LRS, so we need to work out how we connect via the CRSF protocol, and this tells us the information we need to know. With ArduPilot firmware, we need to connect it to serial 1 because that has DMA enabled. When we are setting up the serial port number 1, the protocol we use is 23. So ArduPilot uses a lot of these little codes to enter parameters. So if you remember that, serial 1 protocol has to be 23. Now let's go back to the ArduPilot website. And we can just sort of work down this list here, and that will sort of give us most of the information that we need. Now, if we go to the choosing an autopilot section here, there's some good information. And if we scroll down, we'll find our board, closed hardware, discontinued boards. That's where we are here. So if we look at the Matek F405-Wing board, it will give some information, sort of the same information that we had on the Matek website. Here's the default UART order. What I was going to show you is on some other boards like the F765WSE, the serial input numbers don't match the UART numbers on the board, so we just have to be aware of that. For example, serial 4 is actually UART 3 and serial 5 is UART 8 on the board. What is equivalent to the ports tab in iNav are the serial inputs here. This is a little bit more confusing than iNav. But we're on the F405-Wing, so we'll stick to that. Here are some battery monitoring numbers that you may need to enter. I haven't done anything about that. And here's the GPS and optional compass if you want to plug them in. But what we're going to do now is download the ArduPilot firmware. Firmware page here, we go to plane because we have a plane, obviously. We scroll down and I would get the latest stable. I think it's this folder here. And then we scroll down until we find our particular board, Matek F405-Wing. Click on that. And these are all the firmware files. This is the one we want, ArduPilot with BL, with bootloader, hex. So we'll download that. Now, an important thing to know is that we can't flash this firmware onto a new board using QGroundControl. We have to use something like iNav or Betaflight. So I'll open up iNav. Here's iNav 6.1. So what we need to do is put the board into DFU mode so that we can flash firmware. That's that little button there. Push that button down. Connect. And we're in DFU mode. Then we go to firmware flasher and we have this local file that we downloaded. It's not an iNav setup, so we can't use the iNav selection sort of panels here. What we do is load firmware local. Find that hex file that we just downloaded and that'll show up as flash firmware. And now we're ready to flash firmware and let's just do that now. So that's going to erase whatever was on there before, probably an iNav setup. Once we get the ArduPilot firmware on the board, then we can go to QGroundControl and update. There we go, programming successful. We can get rid of iNav now, unplug the board, open QGroundControl and plug the board in again. And let's see what happens. There we go. So we can see something's happening. We can see the levels up on the top there are moving around. The direction's moving around. I'm getting warnings that a few components need to be set up, of course. I'm getting a warning that there's no airspeed sensor because there is no airspeed sensor. So let's go to vehicle setup now. And we get all these setup panels. As I said, we sort of just work down this section here. Now, although we've got ArduPilot on the board and it's sort of connected and everything, I found that you can't just set up the plane like this. The elevons just don't work properly. I found the Servo 3, which is the left elevon, was going crazy. And what I had to do was sort of re-download the plane firmware using QGroundControl now that we have ArduPilot on the board. So it's telling us, first of all, we need to disconnect the board. Let's do that. Board is disconnected. Plug it in again. And here we get to choose what we're doing. So it's ArduPilot, that is the operating system used to flash the board. Plane is correct, we definitely want plane. And we have the Matek F405-Wing board, so let's go OK. And that will re-download that plane firmware, I think, in a form that QGroundControl can work with. So there we go, upgrade complete. Once again, we're getting the sensor warning. Get rid of that. Go to the summary, and when it reads the parameters, it will give us that parameter page again. Components need to be set up, okay. Now, something we can do straight away before anything else is set up the sensor or calibrate the sensor. Let's go to the accelerometer. Just like iNav, you need to calibrate the accelerometer. Put in any rotation we have. It's going to be pointing straight ahead, so we don't have anything to select there, but there are lots of choices for mounting options. You can do a simple accelerometer calibration here, but I prefer to do the whole 6 angles. Just like iNav, we'll get an indication of what we have to do, so that's why I've got this little block of sticky posted pads here to use as a brace for the different orientations. So it's telling us hold still and click next. Completed. Next one. Put it on its side. Over the other side. Nose down. Done. Reboot. Okay. Next step is to set up and calibrate the radio and the receiver connection. So here's my model. I do have the receiver bound and set up here, and standard flight control board setup, which is no mixing at all, 100% aileron, elevator, throttle, rudder on the first 4 channels. Express LRS needs channel 5 to be high to work properly, so I've got channel 5 just set to max. And we need a mode switch, and by default on ArduPilot it is on channel 8, so let's set up a mode switch, and I'm just going to use 3-position switch at this stage. You can use a 6-position switch, but I find that the gaps between them don't quite match up with the mode setups, so it's easier just to use a 3-position switch at this stage, and we can turn that into a 6-position switch by using a little bit of programming, which I'll show you a bit later on. Now, before we can calibrate the radio, we actually need to define a serial input. What we're going to do here is just type serial, and remembering what the Matek website said before, we use serial 1. That's this one here, serial 1 protocol. We click on that, and you would think you would just go down and do RC in, but that gives the wrong RC in, and we can check this by clicking the advanced settings and manual entry, and that's the number that it's inserting. So that's only 2, we need 23. Put in 23 and click save. We need a reboot. Okay, let's do a reboot. Plug in the receiver back in. So it's an Express LRS, so RX and TX on UART 1 or serial 1. Now we should be able to calibrate the radio, zero all your trims, yep, and sub trims, and click OK. All right, it'll tell us what to do here. Lower the throttle stick all the way down as shown in the diagram over here. It's actually responding on the channel monitor bit there. Click next. Now move the throttle stick all the way up and hold it there. All the way down and leave it there. That's good. Yaw stick all the way to the right. All the way to the left. Roll stick to the right. And this is sort of setting the endpoints for the stick input channels. Pitch all the way up. Pitch all the way down. Switches. There we go. Click next. All settings have been captured. Click next to write them. So that's good. Radio's done now. Now we can go to flight modes. Flight mode channel 8 by default. You can use different channels, I guess, but I'm sticking with channel 8. So these are the default flight modes. We have return to launch, fly-by-wire A, and manual. Fly-by-wire A is like angle in iNav, but you can see you've got 6 positions on channel 8 for flight modes. We're only using 3 at the moment. Switch up is manual, middle fly-by-wire A, and down is return to launch. Lots of other modes, of course. You can use acro, which I like acro. Cruise, which is very good. That's altitude and heading lock. And we probably should have an auto tune. Then we can, later on, once we've done that, we can change that to a loiter. But as I said, with 3-position switch, we're only using 3 of those at the moment. The switch options over here are extra options. If you're not using it as a flight mode, I suppose you can do other things with other channels. Next thing we need to look at is safety, and these are all the checks that ArduPilot does before it'll let you arm and take off. There's quite a few things here that will stop you from flying. We can also set up some return to launch information here. Return to launch at 100 meters, probably a bit too high for me. I'm going to put that to 70 meters. There we go. Now, moving on to some more parameters. Compass. We don't have a compass, so we can disable the compass there. Don't have an airspeed sensor. What I'm doing is just typing in this search here, and it searches all of the parameters to give you the one you need. We don't have an airspeed sensor, so we can set that up here in airspeed type. That's what it's looking for when we first connect. None. That should get rid of that initial warning when we connect up. Now I'm going to set up some fail-safe as well. Fail-safe. It sort of has two fail-safe conditions, the long and the short. Fail-safe short action circle. What it does initially is when it has a fail-safe, it circles to see if it can pick up the RF signal again. If it doesn't, it will revert to the long fail-safe action. So we'll leave it as circle. Long fail-safe action is set to continue. Of course, we want return to launch, so we'll change that to return to launch. Now we'll look at arming. Let's type in arming. Traditionally, you arm using the rudder stick. It is preset to the rudder stick can only arm it, it can't disarm. But I think you're meant to disarm using your ground control, ground station, but I don't have a ground station, so arm or disarm is what we want. That means your stick to the right to arm, your stick to the left to disarm. You can actually use an arming switch on a channel, but I haven't investigated that yet. Auto servo trim is another setting we might like to use. Servo auto trim, here we go. This is constantly adjust the midpoint of the servos so that when you switch back to manual, it will keep flying level rather than doing your trims on your radio, which you should never do. So I'm going to enable servo auto trim. There's another one here called trim pitch CD. This is the pitch angle offset, a little bit like pitch trim in iNav, where your plane would normally fly with 2, 3, 4 degrees of angle of attack, and this is where you would set the board to reflect that. So 300, so that equals 3 degrees of sort of nose up. Another thing, RSSI type. We need to set the RSSI type to receiver protocol. That way it will correctly read CRSF, RSSI and link quality, and make them available to have on your OSD. Another one is trim throttle. Trim throttle, this is your cruise throttle percentage, 45% throttle. If that's okay for you, leave it as that. I usually put mine down to about 35, I suppose. That seems to work for my planes. Did I? Or 38, I think, 38% trim throttle. Now let's look at the serial inputs again. So we typed serial 0 is the USB, so we don't mess with that, same as iNav, the first UART. Serial 1 protocol is RCN, we entered 23 to give it CRSF. Serial 2 is unused, that is pre-set up for a Mavlink connection, which, to be honest, I don't even think about those sorts of things. Serial 3, GPS, and Serial 4, GPS. Apparently you can have 2 GPSs. It should automatically detect the baud rate and all that sort of stuff, so that's no drama, we just leave that as it is. Okay, so now we're going to set up the PWM connections. So that's motor and servos. Type in servo and it gets a list of all the servos and functions. Unfortunately, it sorts them funnily, so that's 10, 11. We need servo 1. Servo 1 is the motor connection on the F405-Wing board, so we've got some setting up to do. Servo 1 function, they've got a preset as aileron. See, this is where iNav is a lot better. It presets these things. Servo 1 we want as throttle, not aileron. There's throttle there. Save and look carefully, and you can see the servo max and servo min are not appropriate for throttle. Minimum throttle needs to be 1000, otherwise nothing is going to work because it will think your throttle is up when you're connecting things in. Max, you can leave it 1900, I think. Moving on, servo 2 would be the second motor if we had one. Servo 3 is the first of the control surfaces. So we have a wing, so we're going to choose, instead of throttle, we're going to choose left elevon. Save. Now we may need to come back in here and reverse it, but for the moment we'll leave it as it is. And also we can see because it was a throttle, the midpoint trim is set at 1100. We need 1500, of course, for a control surface. See, these are really confusing and actually dangerous things that are preset. Servo 4 or S4 will be the other elevon, right elevon. Now, just because these are called left and right elevon doesn't mean they connect to the left or the right control surface. They are confusing terms. They should be elevon A and elevon B, I think, because they're just going to confuse newbies like me. We may need to swap these over later on just to get the mixing correct on the plane. So that's pretty good for all the servos. Should be able to put the board in the plane and connect it up and start messing around with directions and mixing. If you click in the parameters here, and if we click on tools, I've just had to move it over, of course. You can refresh, reset to firmware defaults and save all those parameters. This is like the diff or the dump, I suppose, for iNav. So let's save that to file. It saves it in a folder called parameters, which it will find again if you're trying to load parameters, and it will save all the changes that you've made. And we can save that, and we can also load that again if we need to, or load other ones. These are all other parameters that I've loaded before. Flight control board is in, arrow pointing forward. I have the receiver connected up there. You'll notice I have the power for the receiver connected to the 4.5 pin because that means it's powered by USB, but the RX and TX go to UART1. GPS go to UART3, and you have to be careful with the F405 board because often the ground and the power pins are in different positions to most other boards. The GPS and the receiver in. Now I've got the elevons, left elevon into S3 and right elevon into S4. We may have to mess with the mixing to get these correct. Now you'll remember I re-flashed the firmware once we connected up to QGroundControl, and that was because the elevon that was connected to S3 was going crazy. It wasn't behaving properly unless I re-flashed. Then it starts to behave properly. So now we can plug a battery in and start to set up the direction of movement of the elevons, because they're just not going to be right straight off unless you're extremely lucky. First thing we have to do is set up the elevon movement for stabilization. You have to do that before you set up the direction for stick movement. So stabilization, we'll put it into fly-by-wire A mode, stabilized mode, and see what happens when you tilt the wing up, and it should come up to counteract that movement. So this elevon's working correctly. The other one is going the wrong way, that's going down. And we lift the nose up, both elevons should come up, and we can see that's going down and that's going up. So they're about as wrong as they could possibly be. So to fix that, we need to connect up to QGroundControl again and change the parameters for Servo 3 and Servo 4. So let's do that now. So let's go back to vehicle setup, parameters, type in servo. Now the options for us are we can reverse each servo, but that's not going to be enough in this case. We can also swap Servo 3 function from elevator left to elevator right. I know this seems odd, but this is the way you do it in ArduPilot. And Servo 4, we say change from elevator right to elevator left. And I also needed to reverse Servo 3. And that got the elevons working in the correct direction for stabilization. So now you can see if I lift the wing up, the elevon comes up to counteract it. Same on the other side, so that's working correctly. And if I lift the tail up, both the elevons come up as well. So that is stabilizing correctly. And now it's time to sort out the stick directions, see if they're working in the correct direction. And ailerons are working okay, elevator is reversed. So we need to go back into QGroundControl and change the RC2, which is the elevator. We need to reverse that input. Once again, connected to QGroundControl, we're looking for RC2, which is our elevator. The RC map pitch is on channel 2, so we need to reverse that channel. RC2 reversed, it's this line here. Click on that, change from normal to reversed, save that. And now with we should have the stabilization working in the correct direction. Yes, yes. Yep, that's all going correctly. And in manual mode, we have everything working correctly as well. All right, I've connected up camera and video transmitter into the board there. So now we can have a look at the OSD. This is the pre-configured OSD. Now there's too much information on the screen for me, and it's the big chunky text that I don't like very much at all. So we're going to change all that in the parameters again. Go to the parameter list, type in OSD of course. QGroundControl only has this sort of listed parameters for OSD. You don't have a nice graphical screen to adjust things, so you really just scroll down this list and look at things that are enabled, and you can basically disable them if you want to. Altitude, we want that on, and you can position them using these altitude X and altitude Y here. I think there's about 15 vertical and 23 horizontal, I suppose, so altitude I can leave there. If you want to enable anything else, you can. Compass enabled, let's lift that one up. I can put that right up the top, I think. So let's change that from 3 to 1. And that will, so you can see that moved the compass bar up the top. Get rid of latitude and longitude, I don't need them. You can see you just disable things and they disappear from the screen. And then you can arrange things however you want on the screen. Now another thing you can do is change the size of the font too. I don't like this big chunky font, and some boards have it available on the board, but the F405-Wing board doesn't have enough memory apparently, so you need to put the font file on the SD card. So if you go to ArduPilot on GitHub and look for fonts, AP OSD, then you get all these selection of fonts that you can use. I like the iNav style, Betaflight style, which is OSD font 2. This one here, download that font 2 bin file. There it is there, download the file. So we have the font 2 bin, and we put that on the SD card in the flight control board, and then that becomes an option to select OSD font here. And if we change this to 2 instead of 0, need reboot to take effect. And there we go, we have the new smaller font. So that's the setup pretty much done. I've brought the plane outside to see if we can acquire satellites. We get all the telemetry and pre-arming messages down the bottom. 4 satellites, we're going well. If you're not getting any satellites, you can look at the connection screen of QGroundControl and have a look up the top at the little satellite icon. And if you can see 100% there, click on the icon, you can see 100 and 100%. That shows you've connected it correctly. If they're just dashes, then you may need to swap around the TX and RX connections. Let's make sure the GPS is actually powered up. 5 satellites getting there. Now if I try and arm before I have a proper 3D lock, it should give me a warning. So I'm holding the rudder stick over to the right, telling me AHRS DCM active. Does that mean I'm armed? I'll disarm now. And it's telling me EKF3 is active instead of arm and disarm. That's a little bit annoying. They do indicate, so we've got enough satellites, we can actually arm it now. So I'll show you rudder to the right to arm it. Now I want an armed message, but instead I get DCM active. I don't really understand that, but it is armed anyway. And I'll just try the throttle, there we are. We are getting throttle action. We're actually ready to fly now. So that's about enough for this video. It's getting a little bit too long. In the next video, I'll show you how to set up the 6 position switch and include auto tune, and we'll go for a flight. I actually already have done a flight and it went pretty well. I'll put a little bit of snippet of that at the end of this, but next one will be more of a setup flight and setting up the 6 position switch or the 6 modes. But that'll do it for the moment. Thanks for watching. See you in the next video.
meant to do that.